This is going to be the second video on compounded interest. In this video, we're going to look at the effects of increased number of compounding periods during 1 year and how that is going to affect the actual amount of interest a person would pay on a 1 year loan. And now the concept that we're talking about here is a thing called the effective annual rate. Okay, so this actually has a few different names. You know, I call it the effective annual rate. You'll also see this referenced as the annual percentage yield, APY, the effective interest rate, the annual effective rate. Like I said, it's got a few different names. Essentially, all we're going to do is we're going to take this formula and we're going to apply it to $1 for 1 year, and the amount of interest that that $1 gains during the year is actually equivalent to the effective rate of return as if interest were charged only once a year. So it basically is a way to convert APRs into actual annualized rates. And so the trick is we're going to, again, take this formula where the present value is 1 and t equals 1. All right. If we do that, here's what's going to happen, right? The future value at time t, well, that's going to be 1. So you're just going to have 1 plus r over m. And if t equals 1, you're just going to have that raised to the m power. Now, what we're actually trying to do here is figure out, again, what a 1 period rate would be, even though we have multiple periods. Now, I know that's kind of maybe a confusing way to say it, but again, we're trying to get back to something more like this, where if I didn't want to do compounding every year, what would be an equivalent number that I could use for a rate that would then only be compounded once per year instead of m times a year. Now, what we would then have to do is recognize that this future value is basically going to be equal to 1 plus this APY. All right. All right, so if we call this effective annual rate the annual percentage yield, this is actually what we're looking at. All right, now if we're actually trying to solve for this effective annual rate or the annual percentage yield over here, we're going to subtract 1 from both sides. And this is our formula. Now again, I call this the EAR, the effective annual rate. A lot of people call it the APY or the annual effective rate or effective annual interest rate or something like that. They're all kind of the same thing. This is a number that is equivalent to 1 compounding period per year, but gives you the same result as this APR compounded m times a year. Okay, so I'm going to erase this, then we're going to do an example to prove that this works. All right, so the example that we're going to do is, and I do apologize, there's a little bit of background noise. We are going to work out the effective annual rate, and again, we're going to need some information. So let's say that our APR is 10%, and our m is equal to 2 periods a year. Now, this is going to lead to very similar numbers as we've seen in some of our earlier examples. That's why I'm using these kind of consistently, so you'll see how this all links together, hopefully. If we're going to invest our money into an account that's giving us 10% per year, compounded semi-annually, twice a year, we might be interested in, okay, at the end of a year, how much money is going to be in that account? Well, we can look at this on a per dollar basis, okay? Because, you know, if we take our total investment here and break it up into a number of single dollar investments, basically what we find is what happens to $1, you multiply it by the total number of dollars that you invest, and that tells you the total ending value. So we can work it on a $1, or we can work it on everything, right? And so I'll show you what that means really quick. Let's say that we are investing $100. Okay, well, if we invest $100, the future value at time 1, right, because we are going to leave this for 1 year, is going to be equal to $100 times 1 plus 10% divided by 2. Well, there are 1 year times 2. Okay, so we've already worked this problem, right? It ends up being 100 times 1.05 squared. And this, right, because again, we've worked this earlier, we know that this ends up being $110.25. Now, if you did this with a $1 investment, and that's the only thing that we changed, the future value would be equal to 1.1025. Okay, and I'll leave that to you to check that math. And you note that, well, if we multiply this times 100, right, 100, then all that's going to do is move our decimal point over, and that's, yeah. Okay, so we do it on $1, we do it on $100. It's mostly just, you know, this is what happens to $1, this is what happens to $100. They are a factor of 100 apart. Just to prove, yeah, we can do this on $1. We're going to get what. So if we start off with a $1 investment, we have already shown that the future value ends up being $1, 10 cents, and 25 hundredths of a penny. Okay, so 1.1025. Okay, now one question a person might ask is, instead of taking 10% and compounding it twice a year, is there an equivalent interest rate where I only compound it once a year? Okay, and this is that APY. Okay, so I'm trying to figure out what rate of return compounded once a year would give me the same future value. So this is where we can use, and again, this is also what I'm calling the effective annual rate here, is equal to 1 plus R over M to the M minus 1. And the M here, right, is this. Okay, so I'm trying to figure out, you know, if I could figure out a rate where M would equal 1 in this formula. In order to find that, I actually have to use the original information. So just so that's not too confusing, let me get rid of that. All right, now we plug in our information. Well, we get 1 plus, we use our R, okay, which is 10%, the APR. Divided by 2 squared minus 1. Well, we already know what this equals, okay, because this is this, all right? So we get 1.1025 minus 1. This is equal to 0.1025, which is 10.25%. And that would be the APY, or the effective annual rate, meaning getting 10% compounded twice a year is equivalent to getting 10.25% compounded once per year. All right? And that's useful because then we can do this and figure out, you know, hey, given the interest rate that we've gotten from our lender, you know, the bank or the credit card company, they're telling me I'm going to pay, you know, 15% per year APR. How much interest am I actually going to have to pay on this loan product? Well, I need to convert that into a APY or an EAR to figure out the actual cost of interest. So in the last video, I mentioned a credit card might be charging 14.99%, let's call it 15, and they might do their compounding daily. What would be the effective interest rate on that, the effective annual rate. So I'm going to erase this and we'll work that one. From that earlier slide, I said, okay, well, what if your credit card company tells you that your interest rate is 14.99% and they are going to compound that interest daily? Right? What would be the effective interest that you'd have to pay if you leave a balance on your credit card? Well, here's what would happen. We would need to figure out the APY, or the effective rate. Well, that then we will use the formula, 0.1499 divided by 365 minus 1. Okay, now this ends up being a very, very small number. Okay, so you're going to have to be careful, you know, when you're doing this on a calculator. I would start in here first, where you take 0.1499 divided by 365, okay, plus 1. All right, well, that ends up being 1.00041, okay, and on and on and on. You want to keep as many of these decimals as you can. Raise that 365 minus 1. Well, working that math, this ends up being 0.1617, or it's around 16.17% effective interest. So even though they're telling you it's about 15%, actually, if you run money on that credit card and leave it, it's going to gain 16% in interest every year. Okay, not 15%. There's an extra percent, and the reason is, well, the interest is calculated every day, and every day there's a little bit more money in the balance because you are accumulating interest, and that interest is drawing interest, and that actually effectively increases your interest rates by over 1%. So this is how we can figure out a number that gives us an equivalent between the APR, the nominal rate, given its compounding interval, and a rate that would work if I only had compounded my money once a year. And realistically, all we're doing is figuring out, well, if I ran $1 through this account for 1 year, how much interest would that dollar earn? Well, that would be a little over 16 cents on $1. And well, that's what percent are. It's per 100. And so if you've got 16.17 cents per 100 cents, well, that's 16.17%, and that's basically your effective interest rate on that account.